Electric vehicle battery manufacturing. Environmental concerns are fueling vehicle electrification. Switching from gasoline to electricity is a vital solution for reducing emissions to avoid the worst impacts of climate change. E-mobility promises a new era for transportation. Triggering the single largest transformation in decades, major automotive manufacturers are embarking on the transition to electric vehicle manufacturing. They are adopting new or replacing their existing processes, technologies, and tools for battery pack manufacturing. Quality is integral to every aspect of the battery pack, from design, manufacture, inspection, and assembly. The choice of materials and construction is defined by the OEM's market segment being addressed. Batteries come in various styles, shapes, and sizes, such as cylindrical, prismatic, and pouch, organized into modules. High-end vehicles and performance vehicles will opt for lightweight aluminum designs. Mass-market vehicles opt for mixed materials that are steel-intensive. There are 6 steps in battery pack manufacturing. Cells are arranged into modules, frames are welded, modules are attached, sealants and adhesives are applied, and covers are secured. Cylindrical cell caps are roll-formed, prismatic cell casings are extruded. On a high-volume production line, battery welding is a process with a narrow time window for assembly and inspection. There are over 3,500 cylindrical battery cells in a typical design, which means there are over 10,000 welds in the assembly. Even with a 99% weld success rate, there will be 100 weld failures that compromise range and safety. It is of paramount importance that each weld is carefully studied and tested. Design for manufacturability starts early in the design engineering process. Can we accurately determine the blank shape early in the design phase to establish material costs? What is the component's true weight, accounting for the material's stretch, thinning, and deformation? Can we determine the tooling costs for this tray early in the design phase to establish should costs? How do we reduce manufacturing-related engineering change orders? Is the design optimized to minimize significant springback issues? Can we lightweight any of these components? Should we consider the use of fire-retardant thermoplastics? Can we study the fiber orientation for its influence on material strength? Stamped battery pack fabrication concept. How can we improve the frame weldment rigidity of the pack protection structure? How do we optimize welding sequences, cooling, clamping, and release times to reduce residual stresses and unwanted deformations? Can we consider the forming history and its impact on the welding assembly during and after the welding process? Virtual lifecycle manufacturing enables connectivity between the digital world and the physical world. The true digital twin enables seamless data exchange and automated workflows between CAE, CAD, CAM, and metrology. How can I ensure a good seal and assembly accuracy for the battery packs? Can we discover the root cause for quality issues by comparing the as-manufactured part with the as-designed geometry? Hexagon's industry-leading CAE CAD/CAM software, coupled with the most advanced metrology technologies for contact, optical, and CT scan inspection, will increase your EV quality. To help OEMs take control of the entire product quality lifecycle, Hexagon is committed to both software and hardware technologies to connect the dots between engineering, manufacturing, and quality control. We are proud to say that our solutions are trusted by every recognizable electric vehicle company and its suppliers in the world. We've created 100% EV to accelerate your successful transformation to e-mobility.